All right, grade 8. Let me show you how to solve some linear equations, um, some simpler linear equations that you probably would have worked with in grade 7 and probably even went further than this in grade 7. But let me show you a couple methods you can use to solve equations. Um, so here's two equations. The first one, x plus 3 is equal to 5. One method of solving an equation is just by reasoning it out. I think probably that's the most useful method of solving a linear equation, is just to reason it out. Sometimes it's hard to do, but in a question like this, we're just trying to figure out what number do we add to 3 to get to 5, and that shouldn't be too bad. We should be able to recognize that, oh, if x was equal to 2, then when I add 3, I get 5. And that's how easy it is to solve, just by reasoning it out. Same with an equation like this. If I say 3 times an unknown number is 15, what's that unknown number? Well, the unknown number is just going to be 5, because 3 times 5 is 15. So this is just a method where we're using reasoning to get our solution. On the other hand, we can also rearrange equations. And equations are going to get more complicated, and so therefore rearranging is a really useful strategy to know. And rearranging involves isolating your unknown variable in your equation. So in this equation where I got x plus 3 is equal to 5, if I wanted to get x by itself, how would I undo adding 3? Well, I could subtract 3, because if I subtracted 3 away from an add 3, they would cancel each other off. Now, if you think of two numbers that are equal, like 2 is equal to 2, what happens if I add 3 to both sides of that equation? What if I times both sides by 2? And so the nice thing about equations is that whatever you do to one side, you can do to the other, and they're still going to be equal. So even though here I've just subtracted 3 on this side, really to keep this balanced out, I have to subtract 3 from the other side of the equation. I have a left side and a right side. And so when I have x plus 3 subtract 3, that's just going to equal x. But if I have 5 minus 3, I get 2, which is exactly what I would get just by reasoning. What about 3 times x equals 15? Well, how do I undo multiplication by 3? Well, I can divide both sides by 3. Okay, now I wrote the divide symbol, but really, let me show you the way I'm going to write it often. I'm just going to write it like this. It looks like a fraction, but you know what? The fraction expression like that, that is the same as divide. So 3 divided by 3 is just 1x, and 15 divided by 3 is 5. And so sure enough, we get the same answer by rearranging that we would by reasoning. I would recommend doing reasoning for simpler ones, but we're going to get more complicated ones where reasoning is going to be difficult. Let me show you an example of a couple of equations which are a little bit trickier to just reason out. Here's one. Sometimes they involve decimals. So something like x plus 7.15 is equal to 13.28. So some of you might be able to still just look at that and say, oh, I know what I can add to 7.15 to get 13.28. But if you don't know, what I would suggest you do is you rearrange the equation by subtracting the 7.15 from both sides. This will make it so we just have x, whereas here, if we go 13.28, subtract 7.15, and take out your calculator, you'll get 6.13, and that's your solution. So sometimes it's easier to rearrange than just to know what x has to be. Another situation where it's nice to rearrange is when we have multiple steps. So for something like 3x plus 6 is equal to 9. Now, a person could probably still reason this out. We're deciding we're going to take 3 and multiply it to a number. Then we're going to add 6 and get 9. Now, some of you might be able to just reason it out still and go, okay, well, if I go 3 times 1 and then add 6, I get 9. So x is going to equal 1. And that's okay. You can still reason that out. But in a rearranging method, this is the way we would go about rearranging it. When you have multiple operations in a linear equation, I try to remember BEDMAS, or for my Americans down south, PEDMAS, but I like BEDMAS better. Brackets, exponents, dividing and multiplying, which are at the same level, and adding and subtracting, which are the same level. So realistically, it's almost like BEDMAS goes like this. Brackets is at the highest, exponents, then multiplying and dividing can be done together, and adding and subtracting can be done together. So but here's the cool thing about BEDMAS. When we're rearranging equations, we actually work the other way in BEDMAS. So instead of looking for brackets and exponents and multiplying and dividing first, we're actually going to start with our adding and subtracting. So when I rearrange equations, instead of worrying about this 3, I'm actually more worried about this adding 6 here. So I'm going to turn around and subtract 6 from both sides of my equation. So I'm going to actually take care of the adding, subtracting that's occurring to x before I worry about the multiplying and dividing. And so what that does is allows me to rearrange this equation. And if I subtract 6 from this side, I just get 3x. If I subtract 6 from this side, I just get 3. Now you could just reason this out, or if you're rearranging, how is 3 attached to the x? It's multiplied, so how do we unattach it from the x? We could do the reverse operation, which would be dividing. So if I divide both sides by 3, then I would get 1. So that's how we would go about rearranging this more complicated equation to solve for x. Let me give you another example. X divided by 3 plus 5 is going to equal -7. So this is going to be a little trickier equation. So we're going to solve for x here as well. But again, when I'm rearranging equations, I worry more about the adding, subtracting that's occurring to x than the multiplying and dividing, first of all. So here, this add 5, that's what I want to worry about first. So I'm actually going to subtract 5 from both sides of the equation. Now this is where our knowledge of integers becomes important, because if I have -7 and I take away 5, so -7 minus 5, I'm actually going to get -12. I'm going to get further into the negatives. Then here, when I get to this point, how would I undo dividing by 3? Well, I'm actually going to times both sides by 3. I'm going to times this side by 3. I'm going to times this side by 3. Then when I multiply both sides by 3, 3 that we're multiplying and dividing by 3, those cancel each other. And so then I just get -36. So this is how we're going to work at rearranging equations to be able to solve for x, which is mostly what we're going to be doing in this unit. So hopefully that helps a little bit and get you started on rearranging equations.